When an asteroid exploded in the sky near the Russian city of Chelyabinsk, there was a rush to collect fragments and find what secrets they reveal about the rock that fell from space. But there was another kind of data locals had collected that scientists were eager to get their hands on. Videos uploaded onto YouTube offer essential clues about where the largest detected fireball in more than 100 years came from. I'm Henry Fountain, a science reporter at the New York Times, and I'm here at the Rose Center at the American Museum of Natural History. In the past, the only way for a regular citizen to really be involved in the scientific process was at the end, at a museum like this one. But with the meteor that exploded over Russia last month, ordinary citizens played an important role. Many captured it on cell phones, and dashboard cameras, like the one that recorded this view of the meteor, are common all over Russia because they are used to settle traffic disputes.
The videos allowed us to calculate the orbit of the object that hit the Earth. Now we know where it came from, and now we know more about what the threat is, what the possibilities for other objects like this hitting.
One blogger in Stockholm, though not a scientist, immediately began figuring out how to use the footage to reconstruct the meteor's path.
When all these videos started coming out, I was watching a lot of them, and then I realized that some of these you might actually be able to find where these videos were taken from. The one that I ended up using in my original blog post actually doesn't even show the meteor at all. It's actually just the shadow of the meteor on these light poles in the central square of Chelyabinsk. And that was more useful because here you actually have something that you can really calculate. You can then suddenly figure out using high school geometry that the angle of the shadow was around 20 degrees. And from there you can sort of measure an inclined plane along which the meteor would have gone through the sky. If you look at this inclined plane, it actually intersected this lake called Lake Chebarkul, where people had found pieces of the meteor. So that was an early sign that this method was working more or less.
Researchers in Colombia were inspired by Gein's blog posts and did the calculations on their own, even more extensively. Researchers in Canada did pretty much the same thing, and they even took nighttime photos from the exact same locations as the video cameras to help get an even better fix on the track of the fireball.
And what the scientists did was they said, okay, we've got all these points of intersection over time from these different cameras. Let's take a bunch of plausible orbits and find out which fits all those points the best.
The meteor is thought to have been 60 feet in diameter and was traveling about 42,000 miles an hour. Video analysis has helped show that it blew apart almost 15 miles above the ground.
Meteorites are some of the oldest objects in the solar system. They're the fossils that allow us to understand how planets form. Understanding where they came from and how they're made tells us where our own planet came from.